Okay, so we're back. Now we're on the back of the notes. So we talked about side, 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 angle, side, angle. Now there's one more we're going to talk about. Well, there are a couple more, but this one is called angle, angle, side. If this one is very, very similar to angle, side, angle. The only difference, A, B, C, D, E, F, the only difference is that when I look at AAS, the S is not between the two A's. So when I draw this, how's this going to look? Well, angle, then another angle. So I'm going to say angle B is congruent to angle E. Now the side is not between the two angles. It's not ASA, it's AAS. So angle, angle, and then this side. That's angle, angle, side. Okay, so angle, angle, side, angle, angle, side. If that's the case, then the triangles are congruent. Okay? All right, so to summarize what we've got here, side, side, side is good. You can use that to prove the triangle's congruent. Side, angle, side is good. Angle, side, angle is good. Angle, angle, side is good. Now there are other combinations though that we need to look at. What if you know that all three angles are congruent? All three sets of angles are congruent. Would that be enough to say the triangles have to be the same? Now I'm going to just draw a quick example here. Let's just use say there's 60, 60, 60. Okay? So 60, 60, 60, that's an equilateral triangle, equiangular as well. If I measure that, I'm going to get some value for each of these. Now here's the thing. I could draw a bigger triangle that's also 60, 60, 60, which is angle, angle, angle. Now you can look at this, we could measure it, but you can just eyeball this and say, look, these are not the same length. These triangles are not congruent. So if you knew that all the corresponding angles were congruent, that's not enough information to say the triangles have to be the same. They don't. So angle, angle, angle is no good. Now the other one here is side, side, angle. Now actually if you spell it the other way, ASS, angle, side, side. That's usually the way that we talk about it, angle, side, side. I'm not going to write that down though for obvious reasons. So side, side, angle or angle, side, side is actually not going to work. You can't say bad words in geometry. I'm sorry. Geometry, angle, side, side does not work to prove triangle congruence. I'll show you why. Okay, just a quick explanation. If I were to take the dimensions of a triangle, if I ask you, okay, you make a triangle with a 45-degree angle, then a side of length 6, and then a side that measures 4.5. Okay, now what you see down here is my finished product. Here's the 45-degree angle. Next to that is the 6. Then I run into a problem. Notice that I have two 4.5s in the picture. I could draw the 4.5 so that it hits this side of the triangle here, or it hits here. So what happens, I've got the blue triangle fits this description. But the red triangle, the bigger one, also fits this description. Which one is correct? Well, actually, they both are. Okay, so here's the problem. If you know angle, side, side, that's not enough information to mean that the two triangles have to be congruent. They don't, because there are two possibilities for this. Okay, so angle, side, side, unfortunately, I apologize to you, angle, side, side is no good. You cannot use that to prove triangle congruence. Okay, now there's one special case of this. If you have right triangles, if you have two right triangles, and you know this. Now you look at this and you say, wait, that's an angle, that's a side, and that's a side. So again, I'm not going to spell it ASS, but angle, side, side, you're going to say, wait a minute, that doesn't work. This is a special case though where you have a right angle. If you have right angles, then what's going to happen is that they will be congruent, because if you did Pythagorean theorem, this third side would have to be the same. If you did a squared plus b squared equals c squared, you would get that these two sides are the same. As an example, if I say this is 6 and this is 10, and I say, okay, find x, you could do x squared plus 6 squared equals 10 squared. Now when you solve this, x squared plus 36 is 100, subtract 36 to get 64, and then take the square root of both sides, you get x is equal to 8. Well, if you did the same thing here, you'd also get 8. And then that would be side, 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 side. So what happens is the triangles will be congruent. We don't call it angle side, side. What we call it is HL, which is hypotenuse, leg. Hypotenuse, leg. Okay, so angle side, side does not work unless it is a right triangle. And then we call it HL. So over here, HL is good. So unfortunately, you can't tell somebody, you can't walk up to them and say, I'm going to kick your angle side, side. But you can tell them to go to hypotenuse leg. Okay, I'll let you figure that out. All right, let's look at some examples here. Directions: are the following pairs of triangles congruent? If yes, what postulate proves them congruent? One thing I suggest that you do on these is to trace what you know. Now you need to have, you've got two triangles here in number 1. Triangle WXY and then triangle XZY. Notice that you have one set of congruent sides, you have two sets of congruent sides, but you don't have anything else. They don't give you anything else. Well, this is a problem. We need more information because you have to have 3 things. You have to have 3 pieces of information to prove this. Here's what you need to look at though. If I trace this out, notice that the long side here, XY, that's in the red triangle. But notice that when I trace this out, the other one, the blue triangle also has XY. They both have the same side. Well, if they do, if they both have the same side, XY does not change in the red triangle or the blue triangle. It's the same. So what I'm going to do, that's my third piece of congruence. I can mark that. The way that I like to mark that is with an X. This is what we call a common side. Common side. They both have the same side. They have it in common. And the geometry reason for this, the property that we say, this is called the reflexive property. Reflexive property. A side has to be congruent to itself. Okay? So now when I look at the red triangle, I see 1, 2, 3 sets of sides. And in the blue triangle, 1, 2, 3 sets of sides. Well, if I look at my list here, 3 sets of sides congruent, side, side, side. Okay, so I'm going to say here, triangle WXY is congruent to triangle. Now let's see, W is going to correspond to Z. Now W to X, that's the mark of 1. So Z, it's got to go to Y. That's the mark of 1. Z, Y, X. That's how I match it up, and we'll say side, side, side. Okay? That's the triangle congruence statement. This is the postulate that proves it. All right, let's look at number 2. You've got one set of sides congruent. Now this means parallel. Parallel does not mean congruent, but that's going to tell you some stuff. When you have parallel lines, remember some of the relationships you can look for. How about a Z? How about a Z right there? That's called alternate interior angles. They have to be congruent. Those have to be congruent. Okay? That's called alternate, I'll say alt, interior angles. When the lines are parallel, then these have to be congruent. Now you might say, well, wait a minute. there's another z here. There's a backward z with the parallel lines. Those also have to be congruent. Okay, so that's true. So let's see, what do we have here? When you look at the picture, in the top triangle, you have two angles, and then you have a side. And in the bottom, you have two angles, then you have a side. The question is, when you look at the list, is that angle, side, angle, or angle, angle, side? It depends on where the side is. Is the side between the two angles? Well, if I look at the way I labeled this, notice here's the side, here are the two angles. The side between the two angles is this one here. So that's not angle, side, angle. That's going to be AAS. Okay? So we're going to say that's angle, side, angle. And the triangle congruence, we could say triangle ACE is congruent to triangle. Now let's see, A is 2 arcs, so that matches up with G. C is 1 arc, so that matches with H. And then there's E. Okay? Number 3, again you have parallel lines. Look for the Z. The Z is one of the most common relationships to have. Alternate interior angles, those have to be congruent. Now we've got one set of congruent angles, one set of congruent sides. Well, what else do we know? You have a side, common side in the middle. Okay, now we've got 3 pieces of information here. Look at the blue triangle. You have 2 sets of sides and an angle. Where's the angle? It's between the 2 sides. It's included. So look at our list here. Angle between the 2 sides is SAS. So what we'll say here for the answer, we can say triangle NDB is congruent to triangle YBD, and that's SAS. Okay, we'll do a few more examples here. Number 4. You have one set of corresponding angles congruent. You have one set of corresponding sides congruent. Now what we're missing, we need something else. The angles may look congruent, but you can't say that they are. We don't know that. Okay? What you do have is a common side. So we've got 3 pieces of information, but we got a problem here. Look at the red triangle. Here's an angle, and here's the 2 sides. The angle is not between the 2 sides. That's not SAS. That's angle, side, side. Angle, side, side is bad. No good. You can't do that. So we have to say that these are not congruent. All right, number 5. This is a right angle. If that's 90, then this is also 90, because they have to add up to 180, so those are congruent. One set of sides congruent. You also have, look at the 2 triangles here. There's the blue one. Okay, I'll do this one in green. They both have this side in the middle. That's a common side. Now if you look at this, we have angle, side, side. Uh-oh, that's bad. Except, you got to think about this, it's a right triangle. If you look at your list, hypotenuse leg, that does work. This is the only time angle, side, side would work. So you could say hypotenuse leg, triangle, let's go LOV is congruent to triangle LEV. That's how they would match up. Okay? And then the last one here, number 6, they have a common side, 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 side. So that's side, side, side. And we would say triangle MAH is congruent to triangle TAH. MAH is congruent to TAH. When you do this, you cannot assume that things are congruent just because they look congruent. Look for parallel lines, alternate interior angles. Look for common sides. If we go back to number 2 for a second, you might have seen, what about here in the middle? What about vertical angles? That's a big one, big relationship. Those have to be congruent. So actually, you could have said angle, side, angle. The side is between the 2 angles. Or you could have said angle, angle, side. Oh, actually, well, for number 2, this should have been angle, angle, side. But you actually have both now. If I label this, this is ASA, but this is angle, angle, side. Okay, so that was a little mistake, but actually you end up with 2 possible answers. All right, that's it. Go ahead and show these notes to the teacher, and then you can do your assignment.